Okay, the first screen you see here is a bunch of example simulation files. So you can ignore this and go to File and just say New Project. Okay, on this screen, you can make a title for this project and just say this is a example. The location of the building currently is North Carolina, Raleigh-Durham. And you can change to different locations by clicking on it. And then you can select a new location in this list. Okay, so you can accept all of that. Okay, so this is the interface of DesignBuilder. It's got a file organizer on the left and a working surface, a working space in the middle, and some help components on the right. And if we turn off the help part, just to make the screen a little bigger, we can click on this little button here. Now the right-hand side panel is gone. Now we have a bigger working surface. In this is a 3D view of the surface, and this is the north arrow. So currently, north arrow is pointing in that direction, which is the green axis. So to model a quick building, you would go to, let me move this out of the way. Okay, you will go to this little button here, which is a red roof house with a plus sign on it. You'll click on that. All right, this is to add a building. And you can just accept all of this default data. You just say OK. All right, now it allows you to draw this building footprint. Okay, so in our exercise, we said that we're going to build a building with a footprint of 150 feet by 50 feet. 150 feet is facing north and south. So you could just randomly start from somewhere in this system and just click on it and drag and try to snap to the red axis and just type in 150 feet. So now we have the first facade drawn, and then you just go to the green axis and type in 50. And then come back, type in 150 again. And then you just snap on the end of that first segment and then click on it. Now we have this building. So if you rotate around this, you would hold the center wheel on your mouse, and you can hold it, and then you can rotate it around. Okay, like this. The second thing that we need to do is to set the window to wall ratio at 50%. So you would go to openings and go to dimensions and just place this sliding bar to 50%. This will automatically enlarge the window so that the window area to the wall area is 50%. Okay, now we can go back to the layout tab. Now you see the windows are bigger. Okay, the next step is to remove the east and west facing windows. So you just zoom in here by rolling the wheel on your mouse, and then just click on that and right click and just say delete. And you click on that, right click, and then delete it. And then go to the other side, click on it, and delete. And click on it, delete. Because we're trying to minimize the east-west facing windows and try not to deal with the solar gains there. Okay. So now our model is basically finished. This is our simple energy model. Now let's talk about the file structure of this model. If you look at the tree on the left-hand side panel, at the very top level, we have the example. Okay, that's the example. Now the example is, you can consider that as a site level, right? So this is your project site. A site might have one building or two buildings. Okay, so in this particular example, our site only has one building, which is building 1 here. Okay, now you can add more buildings to the site, and then you have more buildings showing up under example. Okay, but we have only one building, so that's building 1. If you click on that, and you're at the building level, which is this level here. Okay, this building. Under the building, there is something called block 1. So if you click on that, you will get the space without the roof. You can imagine this as one floor of this building. Okay, this building has only one floor, so it only has one block. But if you have more floors, you will have more blocks. Okay, you might have block 2, 3 under building 1. Okay. And then the next level, if you click on zone 1, okay, now everything is grayed out. You only have lines on here. This is the thermal zones under this floor, in this floor. And currently there's only one thermal zone in this floor. Okay, but you can add more thermal zones in this floor, so you can have multiple thermal zones. And in that case, you're going to have zone 1, 2, 3, etc. Okay, and if you click on this little plus sign under zone 1, you will see that there are 6 surfaces, right? And those are the 6 surfaces of that box, right? That box has 6 surfaces. The roof, which is the ceiling of that zone, okay? And ground floor, which is the floor of that zone. And then 4 walls, okay? The longer walls are the walls facing north and south. The shorter walls are the walls facing east and west. And with these surfaces, you also have these plus signs. You click on, let's say, one of these wall plus signs. Let's select a longer wall. This is 1700 wall. You click on that, and then there are these many windows. Okay, so that's windows located on that particular wall. If you go to one of these shorter walls, click on that, and there's nothing. There's no window on it, right? Because we deleted the window. Right, so if we just kind of hide these. So the way that DesignBuilder organizes the model information is by these tiers of information. It starts from the site to the building and level and the zones within the level, and then the perimeter surfaces of each of the zones. Okay. The idea is that if you change any parameter at the parent level, that the element that's under this level will all get changed. For example, let's say if I like to change the R values of the entire building wall, okay, all 4 walls into a different R value, you would do that either under the building level or the block level. Okay, so if this building has 4 levels, you're going to have 4 blocks, right? But you want to change the walls of the entire building to a different wall type. You will just put your cursor and click on building level, that particular building, and then you will go to the construction part panel and then change the parameters of the walls in here. That's the exterior walls. Then you will change that wall to a different wall. okay? And then all the walls under this level, like all the levels and, you know, the walls facing different orientations, they will get changed. Okay? But if you like to change the wall property of a particular wall, only one wall, you will go to that particular wall. Let's say this wall right here, this is a north-facing wall. You will go to the zone level and click on that particular wall. And then you have that wall highlighted. And then you go to construction and you change the wall type or the glazing type on that wall. Only that wall is affected. The rest of the wall will stay the same. Okay, so this is a very convenient feature. So if you like to change something for the entire building, you just go to the proper tier, okay, and then all the children under that will get affected, but nothing above that tier will be affected. Okay. All right, so now if we go to the site level, we come back to the site level, and then once you click on the site, which is example, you'll see that the tabs are reduced to only 3. So the layout is still here. The location, you click on that, you can also change this location, which is Raleigh-Durham right now, to New York City, for example. Okay. That's the latitudes and longitude of Raleigh. If you change New York, these two numbers will change. And then you go to the site features, and that shows the elevation, above sea level, exposure to the wind. You can you can modify this if you want to. Okay. One thing that you want to pay attention is the site orientation, which is 0, and this means that the north arrow is pointing to the positive direction of the green axis, okay, like what we just talked about. That's the default direction for north arrow. If you like to rotate the north arrow, which means that you're also essentially rotating the building, right? You can change this to 90 or 270. The north arrow will change. But for our exercise today, we're going to keep this at 0. And then if you go to the building level, this is where you can enter a lot of the parameters of your building. So you can go here and change the set points of your thermal zones. You can specify your work schedule in here. Right now it's open office schedule. Okay, let's take all of this as default, not change anything. Construction, this is where you can define the wall types and the window, the opaque walls and the floors and the roofs. You can change the parameters of those or have different wall types. Openings are just for the windows. Okay, so here you can change the window size. You can change the window materials, which is something that we'll look at in a few minutes. And lighting is for electrical lighting. So here there are some parameters that we can modify, and we're going to touch on this in a few weeks. Here is the HVAC system. Okay. We're not going to address this too much in the semester, but because this is an active system. But here you can change this to some popular HVAC system. For example, VV with reheat is actually a pretty popular system, right? You can change that, but it will not affect what we do today. Okay, so you can keep it as fun core unit, and that'll be fine. So if you change that to VV system, all these default parameters for the set points for everything else, you'll be by the default. Okay, you can take all of that for this project. And CFD is for fluid dynamic analysis. We're not going to touch on that. Okay. All right, so let's go back to the layout level, to the layout tab. And let's see. The next step, the next number 4 on the project, on the exercise description is to go to the HVAC tab, make sure the cooling is checked. So it's already checked, and that's fine. Okay. and then perform heating design and cooling design as shown in the online tutorials. So I hope you have watched the tutorials, and the tutorials show you how you can conduct heating design and cooling design, which are these two bottom tabs. There's heating design at the bottom and cooling design at the bottom. Okay. I'm not going to get into that because I think the video on DesignBuilder website showed that pretty well. I'm just going to go directly to number 6, item number 6 on the exercise description. Change the glazing type to double low E 6 millimeter and 13 millimeter with air. Okay, so we'll go to openings and then go to the glazing material, which is the glazing type, like here. Okay, you click on this glazing type, and then there's 3 dots showing up on the right-hand side here. Click on that. And then we like to specify the type of glass for this project. Okay, so you will go to double. That stands for double plane glazing system, and low E. I hope you understand what low E means by watching my video this week. So that's a low E, and it says double low E 6 and 13 with air. Okay, so that's this. Double low E clear 6, 13 with air. Okay, there are more here. Okay, I'm gonna just select this one. Is double low E, E2 equals 0.2. Okay, and then clear 6 millimeter and 13 millimeter with air in it. Okay. So this is just a regular low E glazing. 6 millimeter is one pane of the glass, 13 is another one, and in between the air gap is air, regular air. Okay, so I'm going to just select that one. Okay, so now I redefined my glazing type, right? And then I will do a simulation. So I'm just going to click on simulation tab at the bottom. And just take the default. This will give you a whole year simulation from January 1 to December 31st based on Raleigh climate. And so you just take the default. Okay, now the simulation is finished. It shows you a bunch of graphs like this. So what we want to do is to display the data in tables, not graphs, right? So you go to the left-hand side. Here, let's do a monthly display, because if we do daily display, we have 365 data points. That's a lot to look at. So we're going to just kind of condense this into monthly. So we'll change this to monthly. And data here is all, and that's fine. And then show as graph. So I would change that to number 4 table. Okay. Now we have this monthly display of various performance data of this building. Okay. But this table is fairly small to see. The numbers are so small, and it's hard to process this, right? So we are going to export this into an Excel file. Okay. So you will just place your cursor on top of this table and right-click, and then go to the last one on here. It says Export Dialog. Okay. Once you have this, you will click on Text and Data, and then save this to a file. You click on File, and then you browse, and just kind of put that somewhere else. Let's see. I'm just going to put it on the desktop. Here, the data type, the file type is .dat, and that stands for data. Let's take that and change. Just give that a file name. So I'll say case 1. So this is case 1, right? DAT. So that's output for that glazing type that we specified. Okay, I think that's it. Okay. Export. And then here, there's one more thing that we need to do, which is to change the export type from list to table. Okay. I think that's all we need to do here. Okay. Just change this from export style from list to table and then export. Now we should have a DAT file on the desktop, which is case 1 right here. Okay. So I hope that you have Excel installed on your computer, and that's a very popular software. All right, so you would double click on that. And now it opens up. All right, I'm going to keep this. It opens up in Excel. And now when you do this, you might run into some in between steps. It might ask you how you want to import this DAT file, the file into Excel. And you have to click on some buttons, but mainly you have to say is comma delimited with table. So when you get to that, and you can't get the file to this format that's on the screen, you need to let me know. I can show you what buttons to click to export the file into this. Okay. But if I make these top layers just a bit bigger. Okay. So that represents each of the month, right? So that's January, February, March. Okay. And then there are a bunch of data here. There are some energy data, lighting data, hot water. All these are estimates, and heating energy usage. These are energies, and chiller energy usage, various temperature inside. Okay. So for this particular exercise, we are going to only look at the thermal loads. Okay, I will explain the thermal loads, the definition of those cooling and heating loads when we meet today at the beginning of the class. Okay. But the loads are actually down here, which is zone heating. Okay, so that's all the heating loads of this building. Okay. And then cooling will be total cooling here. Okay. Right, zone heating and total cooling. You can also look at line 22 and 23, zone sensible heating and zone sensible cooling. What is the difference between sensible cooling and total cooling, right? You might already know the answer to this if you watch the video. So sensible cooling is just for lowering the temperature of the air. And on top of sensible cooling, there's also latent cooling, which is to remove the moisture in the air. Okay, so total cooling is most of the time is bigger than sensible heating, sensible cooling, but it's not always the case because sometimes the latent heat, you don't have to remove it. You almost have to do the opposite of that. Okay, when the air is so dry, so you have to. When in that case, your total cooling is actually smaller than your sensible cooling, like in this case, right? So the absolute value of this is 2948. Okay, that's a sensible cooling, but the total cooling is actually 2659. Is actually, we're looking at the absolute value of this, nor the minus sign here is actually smaller. Okay, but it doesn't matter for what we're doing because we're trying to see the window type, how that impact the heating and cooling loads. It doesn't matter what line you look at. So you can just look at zone heating, zone sensible heating, and zone sensible cooling, these two lines. Okay, but this is our first case, our first glazing type. So now I'm going to go back to DesignBuilder, and I'm going to go to Edit, and then Layout. Okay, so I'm coming back to here. I'm going to change the glazing type to a different type list as indicated in our description. So I'll go to Opening, and then go to Glazing Type. And here we want to identify a different one. So I'm going to select Low E Tinted. Okay, Low E Tinted, which is right here. Right here. Okay, that one. Okay, tinted. Instead of clear, we selected tinted 6 millimeter and 13 millimeter with air. Okay, I think the first one I should have selected that one because the E2 is both of these will be 0.1. Okay, the E2 represent how much you do the low E, the level of the low E. So you know, if we only want to look at clear versus tinted, we should probably keep this low E value the same. So the first simulation, I should have selected 0.1, yes. And then the tinted, so I'm going to select that one. Everything else is the same except that the glazing is tinted. Okay, so I'm going to select that one and then say OK. So now I've just changed the glazing. Okay, nothing else. Only the glazing is different. So I'm going to do the simulation again. So between the two types of the glazing, the tinted should give you less solar gain in the summer, but it will increase your heating loads in the winter because you could have gotten much more solar radiation in the winter, but because you have used tinted glazing, you don't have as much solar gain in the winter. That's going to hurt your heating loads. But it'll help you, the tinted glass will help you with your cooling loads, right? It will lower your cooling loads. That's the point of this exercise, okay? So I'm gonna right click on this again and export this into a new file. And then I'll call this case 2. Just remember case 2 is tinted. Why don't I just call this tinted? Yeah. And export and change that to table, from list to table, and then export. Okay. Now I should have a new file here that's named case tinted, right? So I'm going to double click on that. So now this is the tinted part of this. And as I said, we're only looking at the zone sensible heating and zone sensible cooling. So I can just grab these two lines here. Okay. I don't need other things. I just need to have these two. Sorry, that's wrong. Wrong. So zone sensible heating, zone sensible cooling. So I'm going to right click and just say copy. And then I will go to this file, the case 1 file, and I will just click on one of the lines here and right click and just insert copy cells. So I just basically I copied the tinted data, only those two lines, I'm going to give that a yellow background just to tell the difference, right? The yellow ones are the tinted, and then I'm going to grab these two lines out. Okay. And then I'll add a line between. Okay. So these two lines here, these two rows, that's clear, and the yellow are tinted. Okay. And we want to compare the heating of these two. Okay. So let's grab the heating. So I'm going to move the heating to here, and then move the other case, the tinted heating, because I want to compare the heating loads of these two cases, right? So I'm going to select, so actually I'm going to change this to heating clear, right? So that's a heating data clear glazing, and this is heating tinted, okay? All right, and then I will select all of this and make a chart. So you will select that, you will go to insert, then the chart, right? Just kind of do a chart, and that shows these two rows of data graphically. So this is a heating load, and that's in the winter, right? So when you interpret this data in the summer, that's the summer, okay? So there's almost zero, right? Because you don't do much heating in the summer, but in the winter you're going to see these a few months, right? You're going to see a difference. So the tinted, which is the orange line, will need a higher heating loads, right? This is the heating sensible loads, right? So that means that if you use tinted glass, you're going to have to heat the building more because you don't have as much solar gain from outside, right? But the clear glazing here will give you lower heating loads, right? Because it's clear, is emitting solar gain. You don't have to burn as much energy inside the building to heat to the same temperature. Okay? So that's this. So I'm going to delete this. All right. Now the next step, I'm going to compare the cooling ones. Let me move this out of the way. All right, so I will just kind of delete this line here. So now this is cooling clear, and then this is cooling tinted. Okay. All right, and then I'll do the same thing. So now this is for cooling. So I'm going to select all of this data here, and then go to insert. Now your Excel might have a different interface. So you might have a different way of creating this chart for this data, but this is what's on my computer. Okay, so this is the cooling. Now in DesignBuilder, to represent cooling, it uses negative signs, right? So all of these numbers has negative signs. It just means that you're removing heat from a space, right? But in terms of the level of loads, it's still you're looking at the absolute value, right? So 45,000, that's almost like 4 tons of cooling. And this is, just ignore the minus sign. Minus sign only represents cooling, right? So that's like here, that's in July, right? You are in that neighborhood. That means you have to have like that much of a cooling to maintain the comfort temperature. But here is, orange is the cooling tinted. So the tinted glass, of course, if you look at the absolute value, is smaller, right? For the same month. For example, for May, the cooling loads for tinted is only here, right? Like 23,000. But for cooling, for the clear glazing is like 26 or 27-ish. right? So blue is meaning that we have to have higher cooling loads. You have to spend more energy to remove more heat from the state. That means you're paying more for clear glazing. Okay. So, so that shows this. So this is an exercise. First of all, it kind of get you into the swing of things with DesignBuilder, feel comfortable building a model and be able to do the simulation and then process the data and generate the data, generate some charts or graphs from this data and be able to kind of do some analysis and comparisons. Okay. So again, we ask that you produce a 11 by 17 poster for this and just kind of show this process, show the goal of this project, of this exercise, and show the process and be able to talk about the results and draw the conclusion. Okay, so it's pretty obvious. If you make the glazing tinted, it hurts you in the winter, but it helps you in the summer. Okay. Now you might ask at this point, then how you can draw an overall conclusion about this based on this climate, based on 1 year, right? Should we do tinted or not? Just for energy purpose. Typically, we would just convert heating and cooling separately into dollars, into the bills that you have to pay. Because for cooling, you might use natural gas, okay? But for heating, you might use natural gas. But for cooling, you'll probably use electricity, okay? You really can't compare gas and electricity because they have different prices to kind of give you the same effect. You're burning a certain amount of gas versus you're using a certain amount of electricity for different seasons. It's hard to compare that without converting all this energy requirement into dollars. Okay, so basically calculate after a year how much money you pay between these two type of glazings. Okay. But we're not going to do that for this exercise. As long as you can sort of show the loads difference, we're good for this.